Using promises with complex asynchronous logic with multiple dependent callbacks makes the code difficult to read, manage, and debug. Luckily, there is an easier way to write the asynchronous logic, using async await syntax. Async await allows asynchronous code to resemble synchronous code in terms of its structure and readability. Async await was introduced in JavaScript with the release of ECMAScript 2017, also known as ES8. Since its introduction, async await has become a fundamental and widely adopted feature in modern JavaScript development for handling asynchronous operations. Let us learn async await with the help of a very simple code example. We can then move forward to convert a rather complex promise-based code to async await-based code. Let's define a function myPromise function which returns a promise. As we know, promise can resolve or reject itself. Let's resolve it and pass string success as return data. And instead of resolving the promise immediately, let's resolve it after 3 seconds. We know we can achieve it using setTimeout method. Now, let's utilize this method using then and catch first. Next, we will see how we can use async await instead of then and catch. In this way, we get the success data in the then, whereas the error is received in the catch, and we can utilize data and error as required. Let's now move to the async await way of utilizing the same myPromise function. Let's clear this code. Here we define another method called main function. Let's call myPromise function here. And instead of hooking then, let's put the keyword await with the function calling. As soon as I put await here, I can see an error. The error message states that we can use the await only inside an async method. So, let's add the keyword async before the function keyword to make the main function asynchronous. We can see that the error has disappeared. Await inside an async function does 2 tasks. It stops the execution of the async function and starts waiting for the promise to finish. Promise is either resolved or rejected. If the promise is resolved, await unwraps the resolved value, and you can use the value just like you would with any other synchronous function's return value. You can save it to other variable or constant as return value and utilize it as required. However, if the promise is rejected, the await expression will throw an exception, which can be caught using a try-catch block. Let's see this in action now. We can store the value returned by the promise when it's resolved in a constant. Let's name it data. And then let's utilize it to print its value on the console. Let's run the success value on the console after 3 seconds when the promise is resolved. Let's now reject the promise and see what happens when we run the code. We are sending the string error as an error message. After 3 seconds, when the promise is rejected, we can see the unhandled rejection error on the console. So, we need to catch the error and gracefully deal with it. For that, we have to put the await inside the try-catch block so that if the await throws an error because of the promise rejection, we can catch it and display the error message on the console. We know that we will receive the error in the catch as parameter. For now, we can utilize it to display the error on the console. The string error is the same string that the promise passed when it was rejected. Let's come to a more practical example where we would fetch the details of a user, and using the ID of the user from the fetch data, we will get his posts. Then, we will retrieve the comments on one of the posts using post ID. Here, you can see that each subsequent call to the API will be dependent on the previous one. We will code this example using async await syntax and see how the syntax makes the code cleaner and look synchronous apparently. We will use JSON Placeholder to demonstrate this practical example. JSON Placeholder is a free, publicly accessible fake REST API used for testing and prototyping purposes. It provides a set of JSON endpoints that mimic the behavior of a real API but do not actually perform any server-side operations. It's often used by developers to practice making HTTP requests, handling responses, and testing client-side code without the need for a real backend server. Let's start the code now. Here is some basic code that we will be using in this example. There are a few constants that store URLs. We can see user_URL, posts_URL, and comments_URL. They are all self-explanatory. Also, there is a function fetchData which takes a single URL as parameter and makes an axios-based call to that URL and simply returns the data received in the response. We will use this method to make calls to the URLs stored in the constants above. Let's write a driver function. We are fetching all users here by calling the fetchData function and passing the users_URL as parameter. Since we cannot move forward without getting the data from this function, we have to use await when calling fetchData. We store the data in the users and print it to the console. Now, let's call driver function and run the code. We can see that each user contains ID field and JSON placeholder has returned us an array of 10 user objects. We get the first user by using the JavaScript's destructuring assignment feature. Let us now extract the posts of the first user using its ID. Here, using template literals, we append the user ID to the posts_URL. Since the fetchData is an asynchronous function, we have to put await when calling it. And we can store the return results into a constant. As we can see, it returns the posts where each post has a user ID and its own ID. We can use the post ID to extract its comments. As before, let's append the post ID to the comments_URL and fetch comments. Here, we extract the comments of the first post only. Since the fetchData is an asynchronous function, we have to put await when calling it. And we can store the return results into a constant. When log the results, we can see there are 5 comments on the first post and each comment has post ID as well as its own ID. To catch the error that might occur when fetching data, we have to put all of this code into a try-catch block. Also, it's important to mention that this code doesn't have if statements to make sure the data it gets actually has values before using first user and first post IDs. Adding these checks is easy, but we've left them out on purpose because our main goal here is to learn about the async await syntax. Notice that the code structure appears straightforward and linear, similar to synchronous code, even though each URL call is actually asynchronous. This is where the power of async await shines. Now, let's consider how the code would look if we had used the then and catch syntax instead. Code on the right side makes use of then and catch to make nested calls to the fetchData function. Considering a more complex scenario of a real-world application with many more nested calls, we can see that the await async syntax is clear winner in terms of clean, manageable, and easy to debug code. Hope you liked the content. Please like, subscribe, and hit the bell icon to support our channel. Thanks for being part of our journey.